Jai Shri Gurudev. In today's class, let us learn how to calculate the centroid of this given figure. This is a composite figure that has been given, and we are supposed to find out the centroid of the shaded region. If you can see over here, there is a circle which is not shaded. That means that it has a cutout. We are supposed to subtract it, and the radius of this given circle is 20 mm. First, what we are going to do is break down this composite figure into known standard geometric shapes. That is, we can have a triangle over here. We have a rectangle over here. Say I'm going to call this rectangle as 1, and then we also have a semicircle present over here. Let me call this semicircle as 2, and let us call this triangle as 3. Now the last one, that is the cutout, a circle, let us consider it to be 4. So given that we have already named them, so it is going to be 1 is a rectangle, so we are going to add a rectangle, and then we are going to add a semicircle, we are going to add a right angled triangle. From this, if we subtract a circle, we are going to have a composite figure. So let us write it in the form of a table. To do the tabular column, just consider the first column to be component, the second one area. The units are in mm, so area is going to be in mm square. The next column xi in mm. The next one is going to be yi in mm. Next, this area is denoted by a, so it is a into x, that is mm cube. And the next one is a into y, also in mm cube. So these are the columns that are going to be considered. Components are 4. Component 1, component 2, so we have 4 components over here. Make sure that you are going to write them in the rows. Writing the values in a tabular format is going to be easy when it comes to the calculation part. So the first component is the rectangle that we have considered over here. So for that, if you can see, the breadth is, this is the breadth, it is 60 plus 60, that is 120, and the depth is going to be 100. So the area is going to be 120 into 100. If you multiply, it is going to be this value. The next one is a semicircle. A semicircle of radius 50. So area is pi into r square divided by 2, because it is a semicircle. If you solve this particular value, you are going to be left with a number of 3926.99 as your area. The third one is a right angled triangle. This right angled triangle area is half into base into height. Base is 120 and height or your depth is going to be 60. So it is half into 120 into 60. If you solve this particular value, you are going to get the answer as 3600. Alright, the last one, that is your fourth component. Can you see over here that it is a cutout, it is not a shaded region, that, and can you also see that we have written minus, so we are going to subtract it. First write what is the area, that is pi into the radius of your given circle is 20. So pi into 20 square, pi r square but with a negative sign. This negative sign is extremely important. Please do not forget this negative sign. If we are cutting out, it means we are subtracting it from the given composite figure. Hence, writing that negative point becomes very crucial. If you solve it, you will get an answer of minus 1256.63. Now do the summation. So if you do summation of area, you are going to get, let us calculate all the values. So it is going to be 12,000 plus 3,926.99 plus 3,600 minus 1256.63. If you do this, you are left with a value of 18270.36. Okay. Next is xi. So what is this xi? It is nothing but the centroid. If you remember, in the last class we discussed, say for example, we have a rectangle like this, and this is the y-axis and this is the x-axis for this given rectangle. The centroidal axis xx and yy is going to be like this somewhat, and here is the centroid. So we ended up writing from the origin to the yy axis, that is a horizontal distance exists. I'll repeat, from the origin to the yy axis, that means along the x direction I have to calculate the distance. If we are going along the x direction, it is an horizontal distance. Horizontal, we write it as x. Now from origin to x-x axis, from origin to x-x axis, it is a vertical distance. Vertical distance is denoted by y. So this is our xi and yi, what we are trying to find out for every single individual component that we have considered over here. The first component is a rectangle. For a rectangle, as per the formula what we know, it is b divided by 2. So this is the origin point. Over here we have the origin. From here to reach the center of this given rectangle, we need to travel a distance of just 60 mm, or breadth divided by 2. That is, breadth is 120 divided by 2, which is 60. Now coming to semicircle. Semicircle, the centroid is going to lie somewhere over here for the centroid of the semicircle. So this distance is what we know. Based on the previous class, we remember that from this flat surface or from your diameter, this centroid distance is going to be 4r by 3 pi. But we are calculating from the centroid. We are always going to calculate it from the centroid. So to reach this particular point from the flat line or your diameter, it is 4r by 3 pi. But to reach from your centroid, from your origin to the centroid, it is going to be 60 plus 60, 120 mm plus 4r by 3 pi. So it is 120 plus 4. What is the radius of the semicircle? 50. 4 into 50 divided by 3 pi. So if we are going to solve this particular value, we are going to obtain a value of 141.22. 141.22. The next one, that is your right angled triangle. The centroid is going to lie somewhere over here for this right angled triangle. So this is the centroid distance that we are supposed to find out. And along this particular y-axis itself, given that we are taking the point, the distance from the origin, whatever we are going to calculate, is nothing but the centroid of your given right angled triangle. So if we remember, the area is going to be more, or mass is going to be more, hence this is going to be 1 by 3 of your breadth. 1 by 3. What is the breadth or base of your triangle? 120. So it is 1 by 3 times 120. 1 by 3 times of 120, which is 40. The last one, that is your circle. Can you see that from the center of the circle itself, you can see that a line is coming over here and it has been dropped onto the x-axis. So from the origin, what is the distance to that line? 60 mm. So 60 is our xi for the fourth component. We are not going to use a negative sign. We are traveling along positive x-axis. We are definitely not going to use a negative sign. Now we have finished xi column. This column, what is over here? A into x is nothing but area multiplied by xi. That is fill in. So it is 12,000 into 60 for the first one. So it is going to be 72 followed by 4 zeros. The next is 3926.99 into 141.22, which is 55469.53. The next one is 3600 multiplied by 40, which is 144,000. The last one, 1256.63 multiplied by 60 is 75397.8. Please do not forget this negative sign. Make sure you're going to write it over here also. This negative sign is very important and it should not be forgotten over here. Now coming to yi, we are going to travel along the y direction now. That is along the y axis, we are going to find out the centroid. The first one is the rectangle. So for the rectangle, the centroid along y-axis is going to be half of this length, that is d divided by 2. From the origin also, it is going to be d divided by 2. d is 100, so 100 divided by 2. The next one, for the semicircle. For the semicircle, centroid is going to be somewhere over here. So this distance, this line, say for example, I just call it as x-x axis for now. This x-x axis is dividing your semicircle into two equal halves. So this is also going to be just this, whatever is the diameter, divided by 2. This diameter is 100. So the second case is also going to be 100 divided by 2, which is 50. Now coming to the third one, that is the triangle. The centroid lies somewhere over here. So this becomes the x-x axis. We know about this distance first. So this distance is nothing but again 1 by 3 of d, because the area is going to be more over here. D is nothing but the height of this given triangle. Height is 60. But we are trying to calculate the value from origin. So from origin to reach the base of your triangle, we need to travel a distance of 100 mm. So it is going to be, to reach this particular point, the whole distance is going to be 100 plus 1 by 3 of d, or 100 plus 1 by 3 of 60. That is fill in 100 plus 1 by 3 of 60. Okay. So once we get to know what is the value, write it down in the respective row and column. The last one, that is the circle. So this distance is what we are talking about. So this distance is going to be again 100 divided by 2. It is placed at exactly the center of the rectangle. So this is 100 divided by 2, 50. Now multiply area in yi and fill it up in this particular column. So it is 12,000 multiplied by 50, which is 600 followed by 3 more zeros. The next one is 3926.99 multiplied by 50. So it is 196,349.5. The next one, 3600 multiplied by 120. So this is going to be 432,000. The last one, 1256.63 multiplied by 50. So this is going to be 6283 3, 1.5. Do not forget this negative sign. We are multiplying, so a negative sign is going to carry on. Now we are going to write summation a into x and then summation a into y. So add the respective columns. Whatever is the values that you are going to get, make sure that you are going to write it as the summation. Once we get the summation of it, then we are going to apply the standard formula in order to find the centroid for the given composite figure. Summation of a into x is 1343171.7, and make sure that you're going to use this negative sign. If you miss on that negative sign, then definitely the answer what you're going to get is going to be completely wrong. Along with the sign itself, we are supposed to do the calculation. Do not forget the signs anywhere. Cut out means it is subtracted, it is going to be removed. Now summation a into y is 1165518. What is the standard formula? X bar is equal to summation a into x divided by summation a, which is 1343171.7 divided by 18270.36. Similarly, y bar is equal to summation a into y divided by summation a, which is 1165518 divided by 18270.36. Make sure that you are going to do the calculations. Be careful with respect to the decimal point. Usually that is where the mistake is going to happen. In the first case, x bar is 73.52 mm. Focus on the units. Do not miss the units. If you forget to write the units, then it is not going to be clearly expressed. And the next one, that is y bar, is going to be 63.79 mm. So what does this mean? 73.52 mm and 63.79 mm. It just means that over here, if you consider 6 along x bar, it is 73.52. So here it is 60. So somewhere over here I am going to consider. Okay, so this distance from here is your x bar. So this x bar is 73.52 and y bar is 63.59. So say for example, this is your y bar. So this is where the centroid of your entire composite figure is going to lie.